Hello everyone, welcome back to a new tutorial. Today you will learn how to process data locally in your application. Allow me to introduce to you ROM database. ROM database is a library that belongs to Jetpack suite of libraries to allow developers saving data locally in their Android devices. This library comes up with an abstraction over SQLite. SQLite is a local database engine written in C to allow us to handle data locally in our application in general. As usual, you will achieve the objectives of this course with an application that covers those objectives. For that matter, I highly recommend downloading the project from the GitHub repository so we can be in the same page. You will find the link in the description below for this specific GitHub repository. Just make sure to choose the branch starting point. So after doing that, once and for all, I will explain briefly the structure of this project. This project is made in a way that you will only focus on the database section of this course. First of all, we have the Android.xml, we have some permissions, and we have set up the splash screen for the application. In the folder, I have created too many folders. The first one is activity. It will contain the main activity and the main view model. The application package contain the application for dependency injection, DI package that will consist of how to provide the application using dependency injection. The package local, it's the package that will be our concern for this tutorial. I have created, of course, some packages just to organize our workflow. So the DAO will contain the DAO, and the database will contain the definition of our database. The entity will contain our data tables. And the model, of course, we won't expose the entities to our repository. We will map them to some data classes. I just prepared those models in advance. And the relationship between data tables and the repository with some basic data that we will feed to our database. For the presentation or the UI section of our database or our application, I have just added the screen package. It will contain components, some basic components that I have coded for this course, and some screens. We have home screen, user screen, and wishlist screen, and every single screen is going to aim for an objective of our course. And the other files, color, shapes, theme, and typography are pretty much basically the files provided by a default an empty Jetpack Compose application. And I have just defined some constants here in order not to waste time writing those constants. And of course, a screen sealed class defining basically what we are going to need in this application. Here we have the drawables that we will need, and the map of our application, etc. And I have defined here a splash screen, colors, and strings that we will use across the application, as well as the dark theme and the night theme. So this is a brief description of our project, so you won't be confused. So pretty much the section of screen or presentation, it's beyond the scope of our tutorial. We will only focus on the package local, but I want to be clear about this. What I have created here does have nothing to do with how to create a database. It's just a manner to organize our workflow in order to save some time and in order to be more precise. With that being out of the way, in this course you will learn properly setting up database with its main three components, handling relationships between data tables, handling migrations, handling custom data in ROM database. So let's have some fun. So first of all, we need to set up our ROM database. Basically, we will include some libraries in Gradle, the module file. So here I have just prepared this in advance. So those are the main, the four libraries that we have to include to our build.gradle file to allow our project to use ROM database. So after synchronizing your dependencies with the project, your project will be ready for a Roam database. So the main components in Roam database are the database class, which is an abstract class defining our database, and it will connect our application with the saved data. The second component is entities. So entities are basically a representation of a data table. If you are familiar with SQL language, basically a table contains some fields and some records. And in Kotlin or Roam database, it's represented by data classes. The third component is the data access objects. We will refer to it as DAOs. It will handle the methods that we need in our application in interaction with the data. So basically, this access, the DAOs, are going to consist of some methods that's going to allow us to interact with our entities. I will present to you this diagram explaining what happened under the hood. So as you can see here, basically we need an instance of our DAO that belongs to the database. The database class will provide us with this instance. On the other hand, our application will interact with the data by using the DAO. The data consists of instances of entities objects. Finally, our application can perform CRUD operations, for example, using the associated data entities. So enough of theory already. Let's work with an example that I have created for this purpose. We're going to handle a small application, if you will. So the first thing that we have to do, let's create our first entity. So in the package entity, create a new file or data class. Let's call it product entity. It's gonna be a data class. As we said before, an entity is a data table representation. Each instance of an entity is a row of a table. So if we have a table that contains, for example, 30 records, it means that in our Kotlin class, we have 30 instances of a product entity data class. So in order to make this data class an entity, simply annotate it with entity. So the entity annotation, so let's import this first. The entity annotation has a lot of parameters. Among those parameters, by default, Roam uses class name as table name. So to change this, simply annotate, of course, or add the parameter table name. And here I'm going to add the table name that we have defined in the constants, products table. Why I am doing this? Because if you want to, for example, follow some naming conventions, me personally, when I'm working with some Laravel projects, in the Laravel projects, the naming conventions of data table are, they make them, for example, products table. They will name it products table. So that's what I'm following right now. If you click for products table, here you will find here the value is products table. And I'm keeping the entity name as following the naming conventions of Kotlin. And here we have our instances. So inside the data class, we have here the, not instances, but the fields of our entity. So the first field that we will create is an ID. Every entity must have a primary key. So to identify this key with a primary key, simply add the annotation primary key followed by the name of the primary key. Let's name it, for example, product ID. It will be, of course, of type long. Sometimes you don't want to keep this name because if when using the annotation entity, it's going to create for us a table with this field. It's gonna be named product table as shown here. If you don't want to use the Kotlin, of course, naming convention, simply annotate this this field with :info, and :info we will provide here the name that will be used as the field name in our database. So it will be no longer used product with camel case. We will use here underscore, so product ID. This is the name of the column. Good. We will add some other columns that we will need in our application. So the second one is going to be the title of the product. The other one is going to be the price. It's going to be of type double, and a description of our, of course, of our product. It's going to be a string. And let's add some more fancy fields to that data table. Sometimes you want to ignore, for example, some fields. Let's say you don't need to add in your data table the description. Simply annotate it here with ignore. So when annotating a field with ignore, it will not be added as a column in your, or as a field in your data table. So this is pretty much a simple product entity. And as we said before, there are three main components. Now let's create for this product entity a DAO. So let's go to the DAO package and let's create a new Kotlin interface, and let's call it product DAO. The interface product DAO will contain the methods that will interact with the data. First of all, we will annotate this product DAO with the DAO annotation. So inside the interface, we will define the methods, and those methods are basically, in the SQL language, are the statements: select statement, update statement, delete statement, and etc. So let's say, for example, we want to select everything from this data table. So first of all, we will create a method, and here let's call it, for example, get products, and it will give us here, as you know, as you request. For example, you need only one single shot result. So in this case, you have to add this suspending function to your function. And if you want to have a flow of data, basically a stream of data, you don't need actually to add suspending function, but in the return type, it will be of type flow. Let's import flow. And this is basically what we want. So we will benefit from the flow to allow our user to interact in real time with the data. So it will be, of course, a list of product entity, but we're not done yet here. We have to annotate this function with query to specify the query that's going to be performed in this data table. And here we will put pure SQLite code, and that's pretty much it. Now this function is going to give us the list of product entities, and it will give us a flow with those lists. So anytime we will update or remove a product, it will be updated in real time in our application. Let's add a new method that's going to delete for us all the records. Let's say we want to add a new record to our table. So in order to do that, we will annotate this method with insert, and we have some parameters to choose from. The first one is on conflict. It will decide whenever we have, let's say here, on conflict strategy, we have three options. If we have already a record with that data that we want to insert, we can replace this data, the old data, by the new one, or we can ignore this change, or we can abort the whole operation. So let's choose, for example, replace. So whenever we have already existing data with the same data, we will replace that data. And of course, we will identify the data with the primary key. That's why we are using the primary key in this case. If we have, for example, a product with the same ID, of course, it will replace the data for that specific ID. For example, the product has the ID 10, and for example, the title changed to a new title, it will replace the data with the new one. So inside this, it will be, of course, a suspending function. Let's say name it insert product. So, and this method is going to, of course, return, if you want, a long data or return type. Why we do that? In this on conflict strategy of type replace, if the operation succeeded, we will return the inserted data. Otherwise, it will return 1. So this is basically a way to control whether your operation is succeeded or not. In our case, we don't need this actually. And of course, we need to provide here in the parameter what are the entities that we will insert. So for example, here, let's add products. So let's name it products. It will be a list of product entity. Let's assume that we want update, for example, a record or something like that. So we have to annotate the method, of course, with a new annotation. Let's call it, it's called update. It's gonna be a suspending function, update product. And here we will provide the product name or the product as parameter of product entity. When using the annotation update, it will update a record that's been identified with the primary key. So here we have the primary key product ID. So if the primary key exists in our table, it will perform the operation. Otherwise, if the record does not exist in the data table, it will ignore this operation and it will return here along. And if the operation succeeded, it will give us the, of course, there is no need for that, but if you want, you can add it. It will give us the inserted ID. Otherwise, it will, or the updated ID. Otherwise, it will give us -1. So we don't need actually to add this one here. I'm going to add another last method that's going to give us a product with its specific ID. So it's going to be a query. Let's write a pure SQL code here. So select everything from the table, product table, and of course, where the product ID. So as you can see here, we are no longer using the product ID name for the field with a camel case. We are using it with this representation instead of this representation. So where ID equal, and here I'm going to put colon. Afterwards, I will be doing here product ID, or let's just do it an ID. So the ID is going to be the parameter of this function. So we are going to select, so it will be a function, and let's name it get product. As a parameter, it will be an ID of type long, because the ID is a long data type, and it will be a flow of product entity. Why we are using flow, if you might ask? Because we want to have real updates in our application. Simple as that. So this is basically the main operation that you can find inside the DAO. So the last component, so the database abstract class consists of the database definition and a configuration as the main access to data. So in the data package, let's create a new Kotlin class. Let's call it, in our case, product database. It's gonna be, let's see if we have abstract class here. No. So it's gonna be a class. Let's add here, of course, the keyword abstract, because it will be an abstract class. So what we will do, we need to annotate this database or product database with annotation database. So the database annotation has a lot of parameters that we need to take into consideration. The first parameter will be the version of our database. Why we need to specify the version of our database? Every time you make a change, for example, you have compiled, of course, your project, and afterwards you don't like, for example, the name of this created at field. You want to name it to other name, or you want to add simply a new field. In order to allow Roam database to update your field, you need to upgrade your version from 1 to 2. So this is the first parameter. The second parameter will be the entities parameter. It will be an array, and here we will put all the entities of our database. So we have for now only one entity. It will be product entity. The third parameter will be export schema. So export schema will allow us to see the schema as a JSON format in our project. We will see this in detail when we're going to talk about auto migration. By default, it has a true value. If you want to not export your schema, simply do false here. So we want to export, of course, our schema. We won't need this parameter. And the other parameter that we will see in this tutorial, auto migrations, here you will specify, of course, your migrations. So when automating your migrations, you will put your classes that will be handling for you your migrations. Great. So we will remove this for now in order to keep things simple, and we will talk about the inside of the products database abstract class. So this class, of course, will inherit from Rome database, and inside the curly braces, we will put here our DAOs. So our DAOs will be represented by an abstract function, and the first one will be product DAO. It will return, of course, a product DAO data type. Now I'm going to move forward. Let's add the other entities that I want you to see. So the other entity will be the media entity that we will create. As we said before, we can specify here the name of the entity, table name. It will be here media. The fields of this media entity, it will have an ID. Let's call it media ID. So it will contain this entity, the URLs of the product. So long, it will have 0 as a default parameter, and we want it to be a primary key. Going to annotate it with a primary key, and let's change its name to something else. Let's call it here name. It will be, of course, media ID. So we want this media ID to be auto-generated. So in order to do that, we will add a new parameter. It will be auto-generate, and let's give it true. You no longer need to increment manually this ID from 0 to 1, from 1 to 2, or from 3 to 4. It will be auto-generated. So the other fields that you will need. So as you can see here in this diagram, a product has a relation with media. So here we will add a new value or a new field. It will be product ID of type long. So the product ID will be a foreign key, because we want to relate or to make a link between a product entity and the media entity. So product ID is a foreign key, and that's pretty much it. And let's add another value. It will be val URL of that specific image. As I said before, I'm not going to expose the media entity to the repository. So here I'm going just to add a helper function. Fine. So now we need to talk about how to declare or how to define a foreign key. So the entity annotation has parameters that you can choose from. Let's say, for example, you want this product ID to be unique. So in order to do that, we will add an indices parameter, and I'm going to add here index class, and here I'm going to put the product or the ID that you want. I want to specify it with an index. It's going to be product ID, and for the parameter, I want it to be unique or not unique. So in my case, I'm going just to declare it as false. And other thing, if you want to specify the product ID as a foreign key, or to declare basically the foreign keys of your data table, you will add the foreign key parameter, and inside it will be, of course, an array. The first foreign key, in our case, it will be the product ID. So the entity, we have to specify the entity that this foreign key belongs to. It will be product ID or product entity, that's class. The parent colon, so the name of the colon inside for that specific foreign key. So parent colon, it will be so product ID, because in the previous one, in the previous entity, we have here product ID. So we're going to put exactly the name of this one as here in the parent colon, and the child colon, so it will be an array, and the child colon will be the colon inside the other entity, in our case media entity. We have to put the same colon name here, so product ID. And we want, for example, whenever we delete a product, all its related media will be deleted automatically. So we will do on delete, cascade, and same as on updates. So now we are linking the product ID with the media entity. Now let's add some DAOs. Now let's add the media DAO. So for every entity, you have to add a DAO for it. So here I'm going to call it media DAO. Great. So this is the DAO related to the media. And of course, we will add it to the database definition. Here, I will add the media class, media entity class, and I'm going to add for it a DAO. Just keep in mind, every time when you compile your project, every time you add a new entity or to delete an existing entity, you have to increment the version of your database. So this is just a side note. Let's create another entity. Let's give it a name of user entity. It's gonna be with the same thing as the media entity, I guess. Let's add here a new parameter, yes. It's called default value. So if we don't want to insert full name, it's not compulsory in this case. It will be of a default value of empty string. Let's say we want our email to be unique. We don't want our entities, whenever we are modeling our entities, we want to keep them simple. So only we have 3 parameters. We can add here another parameters, but I'm going to add a new entity that's going to be linked to the user entity. So this entity will be called bio entity. So we want to mark, of course, this user ID with a foreign key, because it is a foreign key, in order to link the 2 tables. So here I'm going to add an indices. So the index that I want to specify here, the user ID will be unique. So in order to make this table has one-to-one link, or I'm not going to say relationship for now, link only a user to express the following sentence. A user must have one bio, and a bio belongs to one user. We need to annotate, or we need to indicate the user ID as unique. So if you want to add another bio with the same user ID, the operation will fail. So great. Now we will put our foreign keys. Great. So now we have 2 entities related to each other. Let's create the DAOs for these entities. So briefly, the 2 DAOs that I've added here for the bio, I'm going to insert a bio, delete all the bios from the database. I'm going to update a bio. For the same thing, user DAO, I'm going to add here a new method. It's going to insert for us a user, delete all the user, update a given user, and check if we will check if we have at least 1 user in our data table. Let's add those entities in the database. I'm going to add one last entity that's going to serve the purpose of our tutorial. It will be wishlist. So just imagine this scenario: a user is scrolling throughout the list of products, and the user liked a product, so she's going to add that product to her wishlist. So this is going to be the purpose of this entity wishlist. So this is the wishlist entity. So you won't learn anything new right now. I'm going just to give you the code of the wishlist DAO. So for the wishlist DAO, it will contain insert wishes, add to wishlist, delete all, delete a wishlist, remove from wishlist, etc. So this is basically basic methods that we will perhaps need in our projects. Great. So let's add this wishlist DAO as well as the wishlist entity to the product database. So this is basically how to define a database with its related entities and DAOs. The next tutorial, we will see how to deal with relationships. As I mentioned here, product has a relationship between media, and user has a relationship between the bio, and the wishlist has a relationship between the products and the media. So I hope I was helpful. See you in the next one. Bye-bye.